Hello everyone, so today I'm going to be going through C3 Trigonometry. So, from C2, you should already know these two few identities here. So, we have one that is sin x over cos x is equal to tan x, and sin squared x plus cos squared x is equal to 1. These identities are used heavily in C3, so it's good that you should know them properly. So, in C3, we meet three new functions over here. So the first one is sec x, which is 1 over cos x. We have cosec x, which is 1 over sin x, and we have cot x, which is 1 over tan x. This might be a bit hard to remember at first, but there's one trick that I used to remember it. So if we look at the first identity over here, and we look at the third letter, so 1, 2, 3, is a c, and that tells us that it's 1 over cos x, which is a c. Look at the second one, the third letter, so 1, 2, 3, s. We use that to determine that it's 1 over sin x, because it's s. And if we look at the third one here, third letter is a t, that tells us it's 1 over tan x. That's the main trick that I use to remember it, so it should help. From the previous slide, we know that tan x is sin x over cos x. So if we replace tan x with sin x over cos x, we can determine that cot x is 1 over sin x over cos x. So we don't want to leave this fraction here. So if we times the top and the bottom by cos x, the top, which is 1 times cos x, becomes cos x, and the bottom, which is sin x over cos x times cos x, the two cos x cancel out and you're left with sin x. So that tells us that cot x is equal to cos x over sin x. Here are two more identities that you need to know in C3. So using the basic identity sin x squared x plus cos squared x is equal to 1, and if you divide them by sin x squared x and cos squared x, you can get two new identities. So let's look at the first one here. So if we divide this identity by cos squared x, so sin squared x over cos squared x would give us tan squared x, because sin x over cos x is tan x, so sin squared x over cos squared x is tan squared x. Here we have cos squared x over cos squared x. Whenever you have a fraction with top and bottom same, it becomes 1. So we know that cos squared x over cos squared x is 1 here. And if you have 1 over cos squared x, so if you look at the previous slide, we know that 1 over cos is sec x. So if you have 1 over cos squared x, you'd get sec squared x. That gives us one of our identities here, which is tan squared x plus 1 is equal to sec squared x. Also, lots of people like to remember it as 1 plus tan squared x is equal to sec squared x, which is the same thing, which just these two are switched around. If we look at this identity over here, all we've done is, instead of dividing by cos squared x, we're dividing by sin squared x. So here we have sin squared x over sin squared x, which gives us 1. We have cos squared x divided by sin squared x, so we know that cos x over sin x is cot x. So if we have cos squared x over sin squared x, we should get cot squared x, because we're squaring everything. So here, cos squared x over sin squared x would give us cot squared x. And 1 over sin squared x, so we know that 1 over sin gives us cosec. So if we have 1 over sin squared x, we should get cosec squared x. So these are quite easy to derive in the exam. All you need to know is that once you have your basic, the equation from C2, you can just either divide by cos squared x or sin squared x, and it will give you the other two identities. So now we come to the inverse functions. So we have three new things here. One's arcsine, arccos, and arctan. So in the calculator you would have normally used the buttons that are the inverses here. So sin -1, cos -1, and tan -1. But another way you can write them, that in the exam they quite like to write arcsine, arccos, and arctan, just instead of writing this. A very, very important thing to note is that, for example, when you normally write cos squared x, it's the same as cos x, all squared. However, the powers here are not to do with the indices. They're not an actual power of the whole function. They're just to let you know that they are inverse functions. So example, when you have the function over here with -1, it's not the same as 1 over the function. It's not, the power -1 is not a power for the whole thing. It's just letting you know that it's an inverse function. It's not the actual power -1. So if we have arccos, for example, arccos, which is cos -1, it's not equal to 1 over cos, because that would be saying arc cos is equal to 1 over cos, which is sec, but arc cos is not equal to sec. So that's one thing to bear in mind. These power minus 1s over here, whenever it's arc sine, arc cos or arc tan, you can't just put them 1 over, because you're mixing up the identities then. Now we come to the double angle formulas. Sorry, not double angle formulas, I mean here we have these addition formulas over here. Double angles coming up soon, don't worry, don't get too excited. So we have the first one here, which is sine A plus or minus B is equal to sine A cos B plus or minus cos A sine B. We have cos A plus or minus B is equal to cos A cos B minus plus sine A sine B. And we have tan A plus or minus B is equal to tan A plus or minus tan B over 1 minus plus tan A tan B. Oh, that was a mouthful. So it might seem like quite a lot in the beginning, but the way I've been taught is a bit weird, but once you get the hang of it, it's actually a pretty good way. You might think it's kind of childish, but it's the way I remembered it, and it's kind of stuck in my head now, so I'll show it all of you. So try and imagine sine and cos as two children. Sine is the polite child. He normally lets cos do whatever he wants and doesn't really have a problem. Cos, on the other hand, is quite a naughty child. He always wants everything to go his way and doesn't really listen to anyone else. So, in the first scenario here, sine is here, and there are two cakes, A and B. So sine wants to try these cakes, hence we have sine A plus B. So sine first tries cake A, and then cos, obviously, the cake's left. Sine is trying cake A, so cos starts trying cake B. After that, cos gets a bit hungry because he just had cake B, so he snatches cake A off sine, cos A. So sine is left with B. If you kind of try and understand that, it kind of makes sense. Because sine is the friendly one, he's trying it, and cos snatches the cake A off him. Again, here we have cos A plus B. So obviously, cos being the greedy one, tries cake A, and then he eats cake B as well, and leaves a few crumbs of A and B for sine to try out later on. Cos is the more dominant one, he has everything in the beginning, and sine is left in the end. It might have confused some of you, but it's the way I remembered it. If not, I think they're in the formula book as well, just memorize them. But that scenario helped me a lot. I know the formulas off by heart now using that. You kind of just have to remember that every time cos has something, he has all of it. So here you have all the cos together, here you have cos together. And the last one over here, this is, I think it's in the formula book as well. I don't really have a scenario for that one. But one thing I really need to say is the notation here. So we have the plus or minus notation here. So for sine, well, one thing I remember is same sign. S is sine, S is same. So you have plus or minus here, the same sign is over here. So sine plus, if you have A plus B, you'd have a plus in the middle. If you had A minus B, you have a minus in the middle. For cos, it's the opposite. So if you had A plus B, you have a minus in the middle. And if you had A minus B, you'd have a plus in the middle. For tan, the way I look at it is, whatever's in the bracket here, so if you have a plus, the same part on the top of the fraction has a plus, and the bottom is always opposite. So if you have A minus B here, the top is the same, so it'll be a minus, and the bottom is a plus. This is a good thing to try and remember, because the signs can mess you up if you don't remember them properly. Now, here's double angle. So double angle is basically using these, and so as the name states, double angle. So you have the same angle for A and B. So you put the same angle into both of them, and you can create some new formulas. So if we have the first one over here, so you can ignore it, it's quite a lot on the page, but if we just concentrate on the first one here, so we have sine A plus A is equal to, so if we put in this equation here, if we put A in all of them, you'd have sine A cos A plus, because I forgot to say sine has the same sign, so you have plus cos A sine A. So you have you have sine A cos A here, and you have sine A cos A here. So if you add them together, you get 2 sine A cos A. So that gives you, this is one identity here. Let me just put in a box so you guys can just see it properly. So we have one here. Sine 2A is 2 sine A cos A. This is quite an important one to remember. The next one, so cos, if we put A plus A into there, you get, so cos is always greedy, cos A, and then sine change. For cos, the sign changes, so you have a minus, then you have sine A. So you get cos 2A is equal to, so cos A times cos A is cos squared A, and sine A times sine A is sine squared A. So using this, we have our identities from C2 that here, sine squared x plus cos squared x equals 1. So if we use these and put them into here, so we know that cos squared A would be 1 minus sine squared A. If we put this identity into the equation, we get 1 minus sine squared A minus sine squared A. So then we know that cos 2A is equal to 1 minus, so you have 1 minus here, you have a minus sine squared A here, and a minus sine squared A here. So you get 1 minus 2 sine squared A. Again here, if we, instead of replacing cos squared A here, we're going to change the sine squared A. So we know that sine squared A is 1 minus cos squared A. If we expand this bracket here, we get cos squared A minus 1 plus cos squared A. And then we can simplify to get cos 2A is equal to 2 cos squared A, because you have cos squared A here and cos squared A here. So you add them up, so you get 2 cos squared A minus 1. So these three over here, so this one over here, so cos 2A is cos squared A minus sine squared A. You have cos 2A is 1 minus 2 sine squared A, and cos 2A is 2 cos squared A minus 1. So cos has three different identities that you need to remember. Tan is there's only one for this one, so it's alright. You have tan A plus A is equal to tan A. So remember, the sign is the same on the top and it's different on the bottom. So you have tan A plus A is tan A plus tan A, which is 2 tan A, and 1 minus tan A times tan A, which is tan squared A. So you get your third identity, sorry, not third type of identity, because you've got quite a few for cos. Your third one for tan is 2 tan A over 1 minus tan squared A. Now, that's all for this video. I know there are some factor formula that I think it's called factor formula or multiplication or something like that. It's when you have bracket, like you'll see in the formula book, you'd have a function, then you have, I don't know, p plus q over 2, and there's some stuff like that. But honestly speaking, I haven't really seen any questions on that before. I think I've seen one question in the past papers, but I haven't really seen any questions on there. I think most questions that come up in this form, you can use all the stuff, all these identities that you've learnt before to solve it for perfectly. I've never needed to use them, so I don't think you ever will too. And it's a good thing to just be aware of them in case a question comes up. You can use the formula book and learn it, but I wouldn't say that's important right now. So that's the end of the video. I hope you guys enjoyed, and please leave a comment down below, like, comment and subscribe, and I'll see you guys next time. Bye.